You've probably seen the dramatic thumbnails. A fiery red Mars, a bright comet streaking in, and captions hinting at catastrophe. Tonight we're putting that to bed. The claim that interstellar comet 3I/Atlas is going to hit Mars is debunked. Not unlikely, not maybe. Debunked. In the next few minutes, I'll walk you through the actual measurements, where they come from, and why the impact story is wild speculation built on pseudo-science and misreadings of the data. First, what 3I/Atlas actually is. It's the third confirmed interstellar visitor we've spotted after Oumuamua and 2I/Borisov. It was picked up by the Atlas Sky Survey in Chile in early July 2025. Since then, telescopes from ground and space have watched a perfectly ordinary cometary performance. A brightening coma, a dust tail, and activity that tracks its distance from the Sun. Nothing in its images or light curves suggests alien technology or anything remotely artificial. It looks like a comet, it behaves like a comet, and it follows the physics we expect for a small icy body being warmed by sunlight. Now, the geometry, which is the heart of the matter. The most important number you'll hear in this video is the Mars closest approach distance, roughly 0.19 astronomical units, or about 30 million kilometres, on 3 October 2025. 30 million kilometres. For scale, Mars has a radius of about 3,390 kilometres. The gap is not just large, it's enormous on planetary terms. There is no crossing of paths, no grazing paths, and certainly no collision corridor. Agencies like NASA and ESA have said as much in plain language. There is no threat to Earth or to other planets from this comet. Perihelion, the comet's closest approach to the Sun, follows later in October at around 1.4 astronomical units, just inside Mars's orbit. Again, that is all outside any plausible impact geometry. For Earth in particular, the closest spacing is even larger. This is why you'll see mission teams excited about observing 3I/Atlas, not planning any kind of mitigation. It's a science opportunity, not a danger. How do we know these numbers are trustworthy? Because they come from orbit solutions based on hundreds of astrometric measurements taken over weeks and months. Each observation pins down the comet's position against background stars to sub-arc-second precision. Those points are fitted to a hyperbolic trajectory under gravity with small allowances for non-gravitational forces, things like jets of gas affecting the motion slightly when the comet vents. The result isn't a guess, it's a statistically defined path with uncertainties that are themselves quantified. And those uncertainties matter, so let's address them directly. Even if you inflate the 1 sigma or 3 sigma corridor around the predicted path, the entire cloud of possible trajectories still misses Mars by tens of millions of kilometres. Non-gravitational forces from outgassing can tweak a comet's track, but they do not produce miraculous handbrake turns. There's no realistic physical mechanism that converts a 30 million kilometre miss into a bullseye. The math simply doesn't support the fear. So, if the numbers are so clear, why are we seeing so many videos saying otherwise? A few patterns keep repeating. The first is the casual misreading of ephemeris tables. A closest approach entry gets inflated into collision course, and a routine flyby becomes a cinematic threat. The second is story splicing, commentary pieces speculating about alien technology, without evidence, get blended into the Mars narrative, so people are left with the impression that maneuvers or intent are involved. That is wild speculation. In real science, extraordinary claims need extraordinary evidence, and 3I/Atlas simply doesn't offer it. The observations match a natural comet from another star system, nothing more and nothing less. There's also the problem of pseudo-science framing. You'll see rhetorical tells like, they aren't telling you, they just changed the numbers, or new secret trajectory. But the real process is transparent. Orbit solutions are updated publicly as more data arrive, uncertainties shrink, and the figures stabilize. This is how professional astronomy works. If there were a legitimate hint of risk, it would show up in the solutions and in agency bulletins. Instead, what we see are stable distances and clear statements. Safe pass, observation plans, no danger. Let's quickly sanity check the viral claims using 3 simple questions you can apply yourself. 1. What's the perihelion distance? If it's around 1.4 AU, the comet is moving inside Mars's orbital region, but not anywhere near Earth's. 2. What's the Mars closest approach distance? If the value is about 0.19 AU, that's 30 million kilometres. Translating an AU into kilometres is a good habit because it makes the scale intuitive. 3. Are space agencies preparing observations or mitigations? They are preparing observations from Mars orbiters, from ground-based telescopes, and potentially from heliophysics missions. Observations mean interest, not emergency. Since this is an interstellar object, there's a separate scientific story worth your attention, one that's actually exciting. With coordinated campaigns around the Mars flyby and perihelion, astronomers can probe the chemistry of 3 I/Atlas's coma, measure dust grain sizes, look for isotopic ratios, and compare all of that with comets that formed around our Sun. If you care about how planetary systems build and recycle materials, this is gold. It may help answer whether the building blocks of planets and, eventually, life have common patterns across different stars. That's a big question, and this comet gives us a rare data point. A quick word on the alien narrative. Speculative essays have their place. They can stimulate discussion and propose tests. But when a hypothesis leaps ahead of the evidence, the responsible thing to do is to call it what it is: speculation. Right now, the weight of the data, images, spectra, dynamics, says natural comet. NASA scientists and many independent researchers have been clear about that. The alien tech storyline is catchy, but without supporting evidence, it remains a headline, not a result. Let's return to the 2 dates that matter for viewers following along. On 3 October 2025, 3 I/Atlas makes its distant pass by Mars at roughly 30 million kilometres. Then, later in October, it rounds the Sun at about 1.4 AU, brightens for a while, and begins to fade as it accelerates back out of the solar system. Expect a flurry of observation notes and preprints around those windows. What you should not expect is a sudden pivot from safe to impact. The physics does not allow it. If you come across dramatic thumbnails and urgent tones, compare them to these anchor facts: ordinary cometary behavior, a missed distance from Mars measured in tens of millions of kilometers, and clear, public guidance from space agencies that there is no planetary risk. That's the difference between evidence-based astronomy and pseudo-science clickbait. If this helped cut through the noise, share it with a friend who's been sent one too many doom videos. And if you want a deeper dive into how orbit fitting and uncertainty modeling work for fast-moving interstellar objects, tell me in the comments. I'll make a separate explainer. For now, the verdict is simple. 3 I/Atlas will not hit Mars. The claim is debunked, the numbers are solid, and the science ahead is genuinely worth getting excited about.